add instruction, after that store instruction, and slowly you realize that there is a similarity between add instruction, store instruction and load instruction. Okay, the operations in this add, store and load are almost same, like they have some I can say uniformity. We will see that. Example, let's say add R3, R4, R5. Okay, so here you tell me what are we going to do. First of all, we fetch the instruction. When you have load instruction, what did we do? We fetch the instruction, right? So that's why step 1 is common. We fetch the instruction and increment the program counter, correct? So there is a same model, that's why. So remember one thing, the major principle of RISC is like this. When the instructions are similar, the design will be simple. The circuit to execute that instructions will be simpler, okay? That's why. So RISC instructions are like almost they are all having the same functionality, okay, same operations. Now we will see. First step is same. Second one, decode the instruction. Yes, that is common to everything, and read the contents of source registers R4, R5. Here we have to read R4, R5 their contents, okay. Same thing, like just compare with load. There also we did the same kind of stuff. The third step, in the third step we did computation, right? That means we did addition. Here also compute the sum which is already read here. R4 value, R5 value we read into some registers, then take that R4 and R5, connect to the adder, that's it. In this third step you connect it to adder, that means already we have adder, correct? Now we are using it in the third step, correct? Now adder contains two inputs, and let's say assume that adder is already connected with some registers like this. Now the only thing is, if you say my dear adder please add, automatically it will add. The only thing we have to supply the data. So the supply of data is done at second step. You see, decode the instruction and read the contents of source registers R4, R5. So the contents of R4, R5 might be read here like this, okay. Now R4 will be read here and R5 data will be read here. Then the third step will be just computation. Now after that, fourth step, you see the fourth step, load the result into, you get the result right here, let's say already we have result now after third step. So that result we have to load into destination register R3, obvious, right? Now we have to take this data and we have to go to, already I told you that we have a register file, correct? Register file. In register file, so there will be a register called R3, and sir, where is the address of R3? Instruction already contains address of R3. So now go there and simply write the data, correct? That is what the meaning of this one. Load the result into destination register R3. Already we have address of R3. Simply enable that register and write the data. That will be done in step number 4. Sir, what about step number 5? Already operation is done, right? I mean everything is done, nothing to do. So in the step 5 we can keep quiet, correct? But what we do is, rather than keeping quiet here, we keep quiet in fourth step. I will tell you the reason. In the load instruction, if you recall, what we did, let's say load R1 something. Then in the last step, we loaded the value into R1, correct? So here also, if I do the same thing, then you are going to get benefit. That we will be studying in pipelining. So that's why design should be same. So here you do the fifth step rather than fourth step. So keep quiet, fourth step. So in the fifth step, what you do is load the sum into register R3, so that this instruction will be similar to load instruction, okay. Now when you have similar instructions, then we are going to get a benefit of multi-stage idea, which is in pipelining, okay. Now we will see the next instruction, store instruction. Before that, I will tell you one more thing. Add R3 R4 hash 1000. What is this? Recall, add instruction, correct? What is the difference between R3 R4 R5 and R3 R4 hash 1000? This is immediate addressing mode, correct? That means here we have to add R4 and directly value 1000, correct? But in this one, we are going to R4 and R5 and we are reading two registers here. We are only reading one register and another operand is direct, correct? So, I mean immediate. For that, So there is no much difference I want to tell you. So fetch the instruction, same. Then decode the instruction and read the contents of source register R4. Only read R4, correct? Next, compute the sum R4 plus 1000. Then fourth step, keep quiet. Now fifth step, load the sum into register R3, correct? So that's why there is no difference between add R3 R4 hash 1000 and add R3 R4 R5. So that is what the idea in RISC instructions. Almost all the instructions are quite similar. Such a way they carefully planned it. Now we will see store instructions. If you see store instruction, store R6 x of R8. Now x is directly supplied here, example it is 100. Then what are we going to do is, we are going to read register R8, assume that its content is 200, R8's content is 200, then the 200 and 100 will be added, 300. So we will be storing the data which is in R6 into a memory address 300, correct? Now we will try to understand it into 5-stage problem. First step, fetch the instruction. It is like load and add, fetch the instruction and increment the program counter. Second step, decode the instruction and read registers R6 and R8. Same thing there also, in add also we have decoded the instruction and we read register R4 R5. Here we are reading R6 and R8, correct? So it is quite similar to add instruction, correct? Now third step, compute the effective address x plus R8. We know how to compute it, correct? So this is the third step, which is exactly equivalent to load instruction step and exactly equivalent to add instructions third step, right? That's fine. So fourth one, now store the contents of register R6 into memory location x plus R8. In the fourth step, what we are doing is, we are storing the contents of register R6 into memory location x plus R8. Already we have this address, let's say 300. Now we are storing the contents of this register R6. Already we have R6 in the instruction. Take that R6 and take the data and directly store into memory. That we can do in the fourth step. Fifth step, nothing to do. Then keep quiet. So in that way, so store instruction can be understandable in 5 stages, correct? Now finally we have seen load and add and store, correct? Load contains 5 steps, but add contains only 4. Store also contains only 4 steps, but that 4 steps are quite similar to that 4 steps of load and 4 steps of add, right? In that way we have instructions. Now since all the instructions are almost similar, then the circuit design to execute these instructions will be uniform, otherwise simple. Okay, that's why we the designers decided to design the instruction set like this. Okay, now we are and especially focusing on RISC instructions, correct? So we are not going to talk about CISC instruction, which is a little bit complex and that is not suitable for pipelining. But our major goal is understanding RISC instructions and understanding the pipelining and getting the foundation for the pipelining topic. That's why. Okay, in this topic what I am going to teach you is how these instructions are generally otherwise how these instructions are going to be executed, and what is the similarity I already taught you. Now what we are going to do is, now we are going to understand the circuit, right? Sir, please teach us what is the circuit, like how that circuit works. Okay, we will see that.